this video, I want to demonstrate some capabilities related to service discovery in a Micronaut application. So of course, in a microservice architecture, often you've got multiple services and they need to be able to find each other. And I want to demonstrate some of Micronaut's capabilities related to that. So I'm going to create a couple of projects here, one called backend and one called front end. And notice that I'm adding the discovery console feature to each of them. And we'll talk a little bit more about that when we get into the projects. And just to make it easier to load these things up in the IDE, I'm going to create a Gradle wrapper at the top level and create a multi-project build just to make this thing easier to make this pair of projects easier to import into the IDE. And now I've got the projects loaded up in IntelliJ IDEA, and I've added a little bit of code to the project, but we're going to look at 100% of the code that I've added, so you'll know exactly what's going on here. But watching me type code is not the interesting part. So when I created those projects, I created each of them, the back end and the front end projects, which are both here. I created each of them with the Discovery Console feature. And a couple of things happened as a result of specifying Discovery Console. One is some dependencies were added to my build.gradle file to pull in some relevant Micronaut libraries to take advantage of Micronaut's service discovery support. And had the projects already been created without specifying that we wanted to use Discovery Console, I could simply add the dependencies here as you would expect and carry on from that point. But because I expressed that I wanted to use Discovery Console when I created the project, those dependencies were already added. And another thing that was added to my project initially at application creation time, so I didn't have to type any of this, this is there by default, is the config you see here from lines 7 through 12. And so what's going to happen when this application starts up, so we're looking at the back-end service right now, is when the application starts up, it's going to register itself with Consul, so other applications in the microservice architecture can find it. And in order for the back-end application to register itself with Consul, the framework needs to know where Consul is running. And the way, or a way to tell Micronaut where Consul is running is by setting the console.client.default zone config property. So the value that we're assigning to that property here is expressed right here. And when I run the application, the value of default zone is going to be localhost :8500. The way this syntax works is if you've got an environment variable named console host set, then this expression right here will evaluate to whatever the value of that environment variable is. And likewise, if you've got a console port environment variable set, the value of this expression will evaluate to whatever that environment variable's value is. And I don't have either of those set. So I've provided the default generated config file here provides a default value for both of those. The console host and the console port. And so again, because I don't have those environment variables set, default zone will be equal to localhost 8500, and I'm going to have Consul running on localhost on port 8500. So when the backend service starts up, it's going to register itself with Consul, and that config setting is how the framework knows where to find the Consul. So all of this is default. I haven't changed any of this. This is what was created as a result of mn create app. At least this console config is what was created. The only thing that I've changed in this config file is I've added lines 5 and 6. And what that's about is by default, when you start a Micronaut application up, it will start on port 8080. And if you want to specify a port number, a way to do that is to assign a value to micronaut.server.port and specify whatever port number you want the thing to run on. For example, what you see here would cause the application to start on port 8086, of course. And if the value of micronaut.server.port is -1, that will cause the service to start on a random port. And we, in fact, want the thing to start on a random port, and that'll become it'll become clear why we want that in just a bit. So this is the only thing that I've changed in this config file is I added server port and assigned it a value of -1. The rest of this was there when I created the project. And I've added this controller to the project, and it's a very, very simple controller. It's got a single endpoint in it, so if I send a request to /greet/Jeff, this code here gets executed, and I'm going to keep the code in the application ridiculously simple. The idea here is to explore service discovery capabilities. There's a whole lot of really cool and powerful stuff we could do in a controller, of course. I'm not going to get into any of that. We're going to keep the controller super simple and just focus on service discovery. So this is the entire set of capability that the backend service has to offer. So it publishes an endpoint at /greet/ and then so you supply a name as the second part of, or the last part of the URL there. And in a bit, once we get through all this, we'll start it all up and you'll see how that works. And I've also got a logger added to this controller so we can tell when this endpoint was executed. And when we get through the demo, we'll see why that's going to help us understand some of the things that are going on in the app. So that's the extent of the backend app. So I created it using the command you saw a moment ago, mn create app, specified that I wanted to use Discovery Console and named the app backend, named it backend. I've added server port to be -1 and added this controller. And that's it. So let's take a look at the front end project. The front end project was created with the same command line switches that the back end service was created with. So we've got the same dependencies added here. In application YAML, we've got the same kind of stuff expressed here. We're going to use the same value for default zone. The only thing that I've changed here is I've set console.client.registration.enabled to false. If we go back to the backend service, you'll notice that that is true, and that's the default value that's there. In the front-end service, I'm setting that to false because that config setting tells the framework whether or not this service should register itself with Consul. And I want the backend service to register itself with Consul so the front end can find it. But nothing is going in our demo here. Nothing is going to be looking up the front end service, so it doesn't need to register itself with Consul, and that's why I've set this config setting to false. So what the application, one of the things the application is going to do is the front end service is going to call the back end service. That's what I want, part of what I want to demonstrate. And in order to do that, the front end service is going to make an HTTP call to the back end service. And Micronaut provides a really, really simple way to express or to define an HTTP client, and that's what this interface is about. So I've added this interface to the front-end application. It's named Greeting Client, and what makes this interface an HTTP client is that it's annotated with @client. And I've specified the name of the service that I want this client to be associated with. So remember, the code that we're looking at right now is in the front end, and it wants to make a call to the back end. This is the name of the service that we want to make a call to. We're going to see where that name comes into play again in just a minute. But this annotation is what makes this interface an HTTP client. And then I can declare as many methods as I like inside of this interface, and annotate those methods with the same annotations that I can annotate an endpoint with in a controller, like get, put, and post, and so forth. And the way this works is Micronaut is going to generate an HTTP client at compile time, and we'll see how we get a reference to an instance of that class in just a moment. But when I invoke the greet method on that greeting client, what's going to happen is a request is going to be sent to this URI. So /greet/something, and remember, in our backend controller, that's the URI that this endpoint is associated with. So this HTTP client will be associated with this endpoint, right, /greet/something in the backend service. Let's carry on. We'll come back to this in a moment. I'll talk a little bit more about I'll talk about this retriable annotation, and there's a couple more points to it to address about this interface, but what I've just described is enough for now. And remember, we're in the front end project, not the back end project. In the front end project, I've got this front end hello controller is what I've called it, and this is all of the code that's in the controller. So I've added a constructor to this class that accepts a greeting client, and the greeting client is the interface we were just looking at. And Micronaut is going to recognize that this constructor is here at compile time. It's going to recognize that this constructor is here and configure the dependency injection container to know that when an instance of the front end hello controller is created, that the greeting client needs to be passed as a constructor parameter. And we're going to use that greeting client in this endpoint that I'm defining in the front end controller. So in the front end controller, I'm defining an endpoint at /hello/something. So if I start up the front end service and send a request to that URI, this endpoint will be executed. And what we're doing here is invoking the greet method on that greeting client interface that we just looked at. That's going to make the remote HTTP call to the backend service and get something back. And here I'm simply converting the result to 2 uppercase just so we can see the effect of some transformation happening in the front end service. So we're going to send a request to the front end service. The front end service is going to send requests to the back end service, get a response, convert the response to uppercase, and then whatever the result of that is the actual response we're going to get from our initial request. So let's start the application up and demonstrate some capabilities that the application has, and then we'll come back to this code and address just a couple more points. Now the back-end service and the front-end service are each going to be communicating with Consul, and they each expect Consul to be running on localhost on port 8500. So I'm going to start up an instance of Consul on port 8500. And a simple way to do that is with Docker. So with this up and running now, with Consul up and running, I'll be able to, when I start up our front end and back end services, they'll be able to communicate with this instance. And with Consul up and running, now I can look at the browser interface and notice that there are no instances of the back end service registered with Consul just yet. So let's start some of those up. There's one. There's another, and we'll start just one more. So I'll have 3 instances of the backend service up and running, and then I'll also start one instance of the front end service. And remember that what's happening is that the backend services are registering themselves with Consul, and the front end service is going to look them up by way of Consul. So if I refresh this interface now, you see there are 6 nodes of backend associated with the backend service, and half of those are health check nodes. So since I started up 3 instances of the backend service, we see 6 nodes. So there are 3 separate instances of backend. Each reached out to Consul and said, hey, I'm here, I'm running, here's my name, this is my machine name, which is localhost in this case, and here's my port number, which will be some random port numbers, right? So this one started on port 16579, 16943, and so forth. And our front end is running on port 8080. And the front end, remember, is going to be communicating with the back end services, and it doesn't know where they're running. No, we didn't know these port numbers ahead of time, and that's where the service discovery engine is going to come into place. The front end service is going to reach out to Consul and say, where are the back end services? And Consul is going to let the front end know about the 3 instances that we just started up. And with all of those running, so I've covered up the front end service, we don't need to see that at this point. But I want to demonstrate what happens when I send a request to the front end service and at a URL like that. So one, notice that the response is all uppercase, so that's evidence that the front end service really did receive the response from the back end service and then transformed it to uppercase. And down here you see this piece of logging output from one instance to the back end, and that tells us which of the back end services handled that request. So if I send the same request multiple times, you'll see that we're round robining through all of the back end instances that the front end discovered by way of Consul. And if I were to kill one of them, so now there's only 2 instances running, what will happen now, and it's a little hard to tell, you'll have to watch these timestamps to tell that what's happening, but that request was handled by this instance, this request was handled by this instance, and now we're round robining through the 2 that are up and running. And the fact that this one has been stopped doesn't interrupt the front end service from working. And that's one of the interesting capabilities of our HTTP client and the service discovery stuff that this simple demo is taking advantage of. So let's jump back into the code and talk a little bit more about that. So we're back in the front end hello controller, and all those requests that we were just initiating with the curl command in my terminal there, all of those requests were being sent to this endpoint, and this endpoint is invoking the greet method on the greeting client, getting a response, and then converting the response to uppercase. So this is where that remote HTTP call is being made from the front end service to the back end service, and we're doing that by interacting with the greeting client that was injected into our constructor when this controller was created. Let's go back and take another look at that greeting client. And on line 8, notice that I've annotated this HTTP client with @retryable. And what that indicates is we want this HTTP client to automatically participate in to automatically impose some retry logic. And what the delay is about is you get to specify how long should the system wait after a failed call before retrying. So what's happening when this HTTP client is initialized is Micronaut is reaching out to Consul to find the services with this name. Right? Remember, the code we're looking at right now is in the front end, and the front end wants to discover all the back end instances. And so what I just said happens. That when this client is initialized, a request is made to Consul to say, where are all the back end services? And in this particular demo, we discovered 3 of them. They were all running on localhost, but they wouldn't have to be. And they're running on some random ports. So this HTTP client knows about all 3 of them. And you saw as I sent multiple requests to the front end that we were round robining through all those back end services. So we've got built-in client-side load balancing in the HTTP client here. And while the system was running and we were generating requests, I stopped one of those back-end services. So the HTTP client knows about 3 of these back-end services, and we're round robining through them. And one of them disappeared. So maybe it crashed or it was down for maintenance or whatever, but it disappeared for some reason. So as we're round robining through them, 1, 2, 3, 1, 2, 3, 1, 2, 3, one of them disappeared. And the next time we got to that one, the system tried to communicate with it and it couldn't respond. And because this @retryable annotation is here, the HTTP client automatically retries by moving on to the next one in the list and waits this amount of time before doing that. So we're waiting a quarter of a second and then moving on to the next one. So as far as the front end controller is concerned, we didn't interrupt the front end controller by bringing down one of the back end services. And this is literally all the code in the front end that expresses that we want to call the back end service. So we don't have any try-catch logic here. We don't have any error handling here. We don't have to impose our own retry logic. All of that happens automatically because we declaratively expressed in our HTTP client that we wanted that retry logic imposed. So that's a really valuable part of the service discovery stuff that Micronaut provides is capabilities like that built-in retry logic. There's a lot more to the HTTP client that I'm not going to get into in this demonstration. What I really wanted to do was introduce the basics of how the service discovery works and how simple it is to tap into a lot of that. So I hope that this was helpful.